Hello students, I, Mrs. Madhavi Mhatre, welcome you all in the next lecture of Mathematics 1. I hope you all are doing well at home. We are studying chapter number 4, Ratio and Proportion. In this chapter, we have covered the topics ratio, then we have seen properties of ratios, and afterwards we have studied operations on equal ratios, which are invertendo, alternando, componendo, dividendo, and componendo dividendo. Afterwards, we discussed solved examples and then we started with practice set 4.3. In that practice set, question number 1 and 2 were discussed by me. 3 was given as homework. And then we started with question number 4. And from that question number 4, the first answer which is displayed here on the screen now, it is discussed by me in the previous lecture. Okay. Now let's go towards the second question from the main question number 4. So here second question is 10x square plus 15x plus 63 divided by 5x square minus 25x plus 12 is equal to 2x plus 3 upon x minus 5. There is a slight difference between question number 1 and 2. In question number 1, what we found is that the 3 terms are in numerator and 2 terms are in denominator. Similarly, on right hand side also, we were having 3 terms in the numerator and 2 in denominator. But here, 3 terms we find on the left hand side and 2 terms we find on the right hand side. So if we do that change, that means if we bring this 2x plus 3 here and if we shift it here, then it will be same as question number 1. So that's the difference. And to change the position of these two, which property we need to use? We need to use alternando. Therefore, here you have to go for alternando. Alter the positions of these two. So 5x square minus 25x plus 12 will be shifted here and 2x plus 3 will be shifted here. Now this question is exactly similar to question number 1. Okay. There we multiplied by 1 upon 4 to equate certain terms. Now here also the same multiple you need to find out. So here what we can find out is 10x square. If we divide by 2x, we get 5x. And 15x if we divide by 3, we are getting 5x. Similarly here, see, if we multiply by 1 upon 5x, then these two terms and these two terms, they will become exactly equal. So to equate them here, you will multiply by 1 upon 5x and then you can solve. Okay, so this is now same as 1 and that is why you will solve this by yourself as a homework. Okay, the first essential step I have given, so copy it down and afterwards you have to multiply by 1 upon 5x on both the sides and simply dividendo will help you. So it will be exactly similar to question number 1. So all of you please solve it by yourself. If you have not understood question number 1, please watch the previous video again so that you can understand it. Okay. Now let's go towards third one. Question number 3, which is different from question number 2. 2x plus 1 the whole square plus 2x minus 1 the whole square divided by 2x plus 1 the whole square minus 2x minus 1 the whole square is equal to 17 upon 8. Now this is different from first and second. This is totally different. Okay. But what you can observe here is the brackets are exactly same in numerator and denominator, only they differ by plus and minus sign. So in this case, you are going to use the property of componendo dividendo. Okay. because the terms are same and plus and minus sign. Whenever you observe such thing, you are going to use componendo dividendo. In question number 2 also we have seen such question. To find value of a upon b, we did componendo dividendo. Similarly here, to cancel certain brackets, we are going to go for componendo dividendo. Okay, so the very first step is by componendo dividendo. So when you do componendo dividendo, always write down numerator first, both the places, in numerator as well as in denominator. Then write down plus and minus sign, and then write down denominator both the places. Okay. Similarly, you will do it on right hand side. So right hand side will be 17 plus 8 divided by 17 minus 8. Okay. So this componendo dividendo you need to do on both the sides. See, as I have said, in the first square bracket you will write numerator both the places, up as well as down. Then plus and minus sign, then again the square bracket, and then you will write denominator. Okay, see, these two brackets are exactly equal. These two brackets also are exactly equal, only they differ by plus and minus sign, which is the property of componendo and dividendo. Similarly here we did 17 plus 8 and 17 minus 8. Now what you can observe is, because of the signs here, see, this is plus 2x minus 1 the whole square, and this is minus 2x minus 1 the whole square. So this bracket will get cancelled in numerator. Similarly, in denominator, 2x plus 1 the whole square will get cancelled with minus 2x plus 1 the whole square. Okay. So these cancellations you can show with pencil. I have done this to make you understand that how they are cancelled. See, these two are having positive signs, so they will be added 2 times 2x plus 1 the whole square. And here this minus and this minus also will give you plus. So these two brackets also will be added, and you will get 2 times 2x minus 1 the whole square. And here 17 plus 8 is 25, and 17 minus 8 is 9. Okay, so it is reduced to this now. You can see it by using one property, componendo and dividendo. We did some cancellations. Okay. Now again, this 2 which is present on both the sides here in numerator as well as denominator, you can cut that. Now what you can observe here is, both the sides are perfect square. See, this is a perfect square of 2x plus 1. This is a perfect square of 2x minus 1. You inside the bracket you can see. And here 25 is square of 5 and 9 is square of 3. So you can take square root on both the sides. So when we take square root on both the sides, we are going to get 2x plus 1 upon 2x minus 1 is equal to 5 upon 3. Now here we are always going to think of the positive answer, because whenever we have seen the ratio, that time we have seen that a, b, c, d are positive integers. So we are thinking about only positive answer. Here we are not writing plus or minus. Okay. Now after this, the next step is to cross multiply. You have to cross multiply. So 2x plus 1 into 3, you will get 6x plus 3. And here when you multiply, you will get 10x minus 5. Okay, so 6x plus 3 is equal to 10x minus 5. Now let's solve it. Shift this minus 5 this side and shift 6x this side. So you will get 10x minus 6x is equal to 3 plus 5. And then here the addition is 8, and here 6x minus 10x minus 6x is 4x. So 4x is equal to 8, and therefore x is equal to 2. And therefore we can say that here x is equal to 2 is the solution of the given equation. Okay. So the question looks quite complicated, but when we make use of these properties, it becomes simpler. Okay. I hope you must have understood it and you must have copied it down. If it is not completed, you please pause the video, copy down, and then again you start the video. Okay. Now let's go towards the next question. Next question, question number 4. Square root of 4x plus 1 plus square root of x plus 3 divided by square root of 4x plus 1 minus square root of x plus 3 is equal to 4 upon 1. This is similar to question number 3. There you were having squares, but here you are having square roots. So the first step is again by componendo dividendo. Then in the numerator the second root will get cancelled and in the denominator the first root will get cancelled. And since there we were having squares, we took square root. But now here square roots are there, so we will square both the sides and then you will get the answer. Exactly similar sum, only in place of square you have square roots. So there we took the square root, here you have to square both the sides. That's the difference. Otherwise remaining all the steps are similar. Okay. So try to solve it by yourself. If you find any difficulty, you can ask me. Okay, now let's go towards the next sum. Question number 5. Okay, 4x plus 1 the whole square plus 2x plus 3 the whole square divided by 4x square plus 12x plus 9 is equal to 61 upon 36. Now here this sum is easy. Only one small change you have to make. See, here there are two brackets, but in the denominator we don't have any of these brackets. But if you observe carefully, this 4x square plus 12x plus 9 is a perfect square of 2x plus 3. Just recall the expansion a plus b the whole square there. Okay. So when you recall it, you know the expansion a square plus 2ab plus b squares. Okay, see. 2x square is 4x square. Then 2 into 2x is 4x and 4x into 3 is 12x and 3 square is 9. So this is a perfect square of this 2x plus 3. Okay, so this we can replace by 2x plus 3 the whole square. Now here see the second bracket is same as the denominator. Okay, so you can cancel it by dividendo. Okay, so you can solve it by dividendo. So write down by dividendo. Dividendo means numerator minus denominator upon denominator as it is. Okay. So see this is numerator written in square bracket minus the denominator is written and denominator as it is. The same operation we are doing on right hand side. So 61 minus 36 upon 36. Okay, now again you can see that because of this minus sign, 2x plus 3 the whole square minus 2x plus 3 the whole square, it will get cancelled. Okay, so cut it like this, but always do the cancellations with pencil. Don't use pen, because when we cut something, if it is wrong, that time also we are using pen. But this is cancellation. This is, we are not cutting the things. Okay, so do it with pencil. Now, after that, we will get 4x plus 1 the whole square divided by 2x plus 3 the whole square, remaining thing on left hand side. And here 61 minus 36, you will get 25. And down you have 36. Again, you can observe that both the sides, everywhere, perfect squares are present. 25 is square of 5 and 36 is square of 6. So we can take square root on both the sides and then we will get it like this. So see, this square will get cancelled. So 4x plus 1 upon 2x plus 3 is equal to 5 upon 6. Because 25 is square of 5 and 36 is square of 6. So we have taken square roots on both the sides. Now as we have done in the previous sum, you have to go for cross multiplication. So multiply here. 4x into 6, you will get 24x plus 6. And here 5 into 2x, that is 10x. And 5 into 3 is 15. So this way you can expand it. See, 4x into 6, that is 24x. 1 into 6 is 6. 5 into 2x is 10x. and 5 into 3 is 15. Okay. Now change the side. Bring this 10x this side and take this 6 that side. So you will get 14x is equal to 9. Okay. See, 10x is shifted here. So 24x minus 10x is equal to 15 minus 6. So we will get 14x is equal to 9 and therefore x is equal to 9 upon 14. This is our answer. Okay. So please copy it down, solve it again, do a practice so that you can understand it better. Okay. Now let's go ahead. Question number 6, which is very much similar to question number 2. There we were having squares, but here we are having cubes. But again, one difference is there. In question number 2, plus sign was in the numerator and minus was in the denominator. But here it is exactly opposite. So to do that change, we have to go for invertendo. Okay. So go for invertendo and then the plus sign will come in numerator and minus will come in denominator. Similarly, here the bigger number will come in numerator and smaller will come in denominator. And then all the similar steps you will follow from question number 2 or question number 3 and then you can solve it. Okay, so again it is same as question number 2 and 3. I have written here 3 but it is similar to question number 2 and 3. So solve it as homework. Okay, question number 3 you see there you are having squares and here you are having cubes. That's the difference. Okay, so solve it by yourself. Once again, I am telling if you find any difficulty, you can ask me the doubt. Okay. Now, let's go ahead. So, below that you have this activity. So, this activity is cancelled. Just below practice set 4.3, this activity is given on page number 70. So, this is not there. It is under reduced syllabus. So, take a note of this. Okay. Now, let's go towards the next topic. And that next topic is theorem on equal ratios. Here we are learning about equal ratios. Properties also we have seen of equal ratios. So now the next topic is theorem on equal ratios. So here we are going to think of two ratios first of all. A upon B is equal to C upon D. See, these are two equal ratios. So when these two equal ratios are there, then according to this theorem, we can add all the numerators in numerator and denominators in denominator. And the ratio obtained or the new ratio is equal to the original ratios. This property is called as what? Theorem on equal ratios. See, if A upon B is equal to C upon D, that means A upon B is one ratio and C upon D is second ratio. But if we add the numerators, that means A plus C, and if we add the denominators in the denominator, that is B plus D, then this ratio is also equal to the old ratios. Okay. So this is called as the property or theorem on equal ratios. Okay. Now here we have seen this property for two ratios, but this property is applicable for n number of ratios. Okay. That means if we have n number of ratios here, n number of equal ratios like this, A upon B is equal to C upon D is equal to E upon F is equal to G upon H and so on. But the term should be finite. Okay. So this property is applicable to n number of ratios, means innumerable number of ratios. Only thing that they should be finite. It is not applicable to infinite terms. And here in the first one, we have simply added the numerators in numerator and denominators in denominator. But even if we multiply both the ratios by the same number, like see here, A upon is multiplied by L, C upon D is multiplied by M, and E upon F is multiplied by N. So here we can multiply both the terms of the ratio by the same number, and afterwards also we can add. then also this theorem is applicable here. So it is a general form of the ratio that if we have such n number of ratios, then each ratio is equal to this sum of numerators in numerator and sum of denominators in denominator. Okay. So then you know that when we subtraction is nothing but what? Adding the opposite. So even this sign can be changed to minus also, because when you are subtracting, you are adding the opposite thing. So this this sign can be changed to minus also. Okay, so take a note of this. We are going to make the things simpler by using this theorem on equal ratios. Okay, all of you please write it down, what is theorem on equal ratios. Next, now let us see solved examples based on this theorem of equal ratios or theorem on equal ratios. So first one here is fill in the blanks in the following statements. So all of you please see in textbook and try to understand. X upon 3 is equal to y upon 5 is equal to z upon 4. So here three equal ratios are given. And here we are provided with numerator and denominator is blank. Now let's apply the theorem on equal ratios. See, this is our original ratios and this is what we want. So this is from the second one, the general form. You will find that here the ratio is multiplied by some number. Like here x is multiplied by 5, y is multiplied by minus 3 and z is multiplied by plus 4. So we also have to multiply it. See, x upon 3 is equal to y upon 5 is equal to z upon 4. These are original ratios. And these three new ratios we wrote by observing the question. I want 5x here. So I have to multiply both the places by 5. You know that we cannot simply multiply in numerator. We have to multiply in both the places, numerator as well as denominator. So it is 5x upon 5 into 3. Okay. Then we want minus 3y. That means we have to multiply by minus 3. So multiply both the places by minus 3. Then plus 4z. So for the third ratio, we have to multiply by 4. And after this, we will get the new ratios like this. Okay. So 5 into x is 5x and 5 into 3 is 15. Then here minus 3y upon minus 15 and here 4z upon 16. Now we want this. You can see that all the numerators are added and similarly the denominators also will get added if we use theorem on equal ratios. But you need to write down the reason that how you are adding or why you are adding. You are using the theorem on equal ratios here. So all the numerators are added in the numerator and all the denominators are added in the denominator. Okay. Then here numerator will remain as it is. And in denominator, see plus 15 and minus 15, they will get cancelled. Okay, they have exactly opposite signs. So they will get cancelled like this. And you will get the answer as 16. So in fill up, you will write down the answer as 16. Or you can simply underline it or you can draw the box around it to highlight your answer. Okay. Now let's go ahead towards the next solved example. Solved example number 2. If a upon x minus 2y plus 3z is equal to b upon y minus 2z plus 3x is equal to c upon z minus 2x plus 3y and x plus y plus z is not equal to 0, then prove that each ratio is equal to a plus b plus c upon 2 inside the bracket x plus y plus z. Now looking at the question, you will think that, Bapre, this is very complicated question, but it is not like that. When we use the theorem on the equal ratios, that time you are you will find the answer very easy. So always start with what is given to you, and you can write down that as k. You can take all these three ratios equal to k, or simply you can write down given as it is, but to make the thing simpler you can write it as k. See, so some constant k is taken. All these three ratios are equal, and for those three equal ratios we have taken the letter k. That means every ratio is having value k. We are just considering it for our convenience. Now, what you will find, see here, again observe the question. A plus B plus C, that means the numerators are added. So again theorem on equal ratios is used. That means you are going to add here all the numerators in the numerator and all the denominators in the denominator. So again write down by the theorem on equal ratios. Then instead of writing each ratio, you can write k, because each ratio we have taken as k. If you don't want to take it as k, then you can write down the word each ratio here. Anything will do. So add a plus b plus c added in numerator. Similarly, add all the denominators in the denominator. So see, first one in first bracket plus the second one plus the third one. Okay. Now here what we can observe is we have some like terms. Like see, this is x here, then 3x is here, and minus 2x is here. Okay. Similarly, here you have 2y minus 2y. Here you have y, and here you have plus 3y. Okay, so these are like terms. And these like terms, then we can add or subtract. So here see this x plus 3x, that will give you 4x. And 4x minus 2x, that will give you 2x. Okay. Similarly for y, see this y and plus 3y, it is 4y minus 2y. Again you will get 2y. And then for z also, see this plus z and plus 3z, 4z minus 2z. So in the denominator we will get 2x minus 2x plus 2y plus 2z. Okay. When we add and subtract the like terms, we are going to get like this. But see the question, always observe the question. We want it in this manner. So you can take out 2 common here and then you can write down the final answer. Okay. So got the answer? Isn't it very easy? So finally you can write down that therefore a upon x plus 2y plus 3z is equal to b upon y minus 2z plus 3x is equal to c upon z minus 2x plus 3y is equal to a plus b plus c upon 2 inside the bracket x plus y plus z. Okay, as it is shown in the textbook. See here, this is your final answer. So the question was in the beginning what you feel that the question is complicated, but when you use the theorem on equal ratios it becomes very easy. Okay, now let's go towards the next solved example. Example number 3, which is again little bit different. See, if y upon b plus c minus a is equal to z upon c plus a minus b is equal to x upon a plus b minus c, then prove that a upon z plus x is equal to b upon x plus y is equal to c upon y plus z. Okay. So these are the original ratios given to us. And this we want to prove. Always observe the question. What we can observe here is x, y, z variables. These variables are in numerator. But here, whatever we want to prove in that they are in denominator. So first of all, we have to bring them in denominator. Always start with what is given to you, okay, and think and do the action accordingly. We want this xyz in denominator. That is why invertendo is done. Exactly inverse. Invertendo means numerator and denominator position you need to exchange. So by invertendo, we will get b plus c minus a upon y is equal to c plus a minus b upon z is equal to a plus b minus c upon x. And these new ratios now we will consider as k. Okay. Don't take the original ratios as k. Here, new ratios, whatever we have got, that by invertendo, take them as k. Why to take as k? Because everywhere then we need not write each ratio. Now here, since we have three ratios, we have to apply the theorem 3 times. And always observe the question. See, in the first ratio, z plus x is done. That means first and third ratio is added. In the second one, x plus y. That means third and first ratio is added. And in third one, you have y plus z. That means first and second ratio is added. So always observe the question and accordingly you have to do the action. You have to use the theorem. Okay. Now why I am discussing these solved examples? They are equally important for exam. These questions also can be asked in exams. Okay. So let's see. Let's use the theorem 3 times. So therefore, by the theorem on equal ratios, first z plus x is done. Okay. So above z we have c plus a minus b, and above x we have a plus b minus c. Now here what we can observe is c plus c and minus c got cancelled. Similarly, minus b and plus b got cancelled, and we got the answer as 2a upon z plus x. Similarly, now the second ratio we will write where we want x plus y. So above x you have a plus b minus c. See here also the same bracket. Plus above y you have b plus c minus a. Here also you will find that certain terms will get cancelled like plus a and minus a, plus c and minus c, and then you will get b plus b as 2b and denominator as it is as x plus y. Then finally you will take y plus z. So above y you have b plus c minus a, and above z you have c plus a minus b. So according to the need we are adding the ratios. Similarly here also now certain terms will get cancelled like c plus b and minus b, minus a and plus a got cancelled, and then finally you got 2c upon y plus z. So see everywhere now this is k is equal to, this is also k is equal to, this is also k is equal to. So from these statements 1, 2 and 3 we can write down 2a upon z plus x is equal to 2b upon x plus y is equal to 2c upon y plus z. Then you can observe that 2 is present everywhere. So we can divide everywhere by 2 and then we will get the final answer. Okay. So this is how we can solve the sums very easily by using the theorem on equal ratios. Okay. Now practice set 4.4 which is based on this theorem on equal ratios that we will see in the next lecture. So students, today I am stopping here. We will meet in next lecture. Till that you stay home, stay safe, take care of yourself. Thank you students.